Okay, so I'm going to talk about the microcracking that we've been doing in the Bryan district. And I'm going to go through some background information, research project that we did, some of the conclusions, how the Bryan district and others are implementing this process, what we're doing with the new spec book, and then I'll take questions. So about 15 years ago, we had TTI do a research project for us, and we actually had them go in and review the full depth recycling that we were doing. And we started a real aggressive recycling of our farm to market system in the mid-90s, because that's the first time we got hit with the oil field. I think we lost Burleson and Milam County, almost all the FM system, and so we did a real aggressive rehab, similar to what we're doing again with the reset of the oil that we're having. And so when we first started doing those projects, it was kind of a new design process for us, so we wanted TTI to go look at them and see what problems we were having and maybe what we could do to fix them. So there was really three major problems. We had longitudinal cracking over high PI soils. I think in the Lubbock area, they were having bonding problems with seal coat on fly ash. And then the other problem was excessive shrinkage cracking on cement stabilized bases, except we didn't have that in the Bryan district. So the question was, why in all other districts, when they cement treat the base, do you have excessive shrinkage cracks, but the Bryan district doesn't? And so when I'm talking about the shrinkage cracks, this is just an example, and you can see usually when you do a lot of cement, you'll get these transverse cracks, similar to kind of a jointed concrete pavement. And so from talking with the previous research with Tom, and we're trying to figure out, why did we not have the cracks in Bryan? And Tom had found some stuff that Austria had done where they had microcracked their roads. So we thought, well, maybe that'll work for us, because one of the things Bryan district was doing that others weren't was, at the end of the day, we were opening our roads to traffic. So we felt like the traffic was microcracking the roads, and maybe that's why we didn't have the shrinkage cracks. So we thought we'd do a study and see, how do we roll to achieve the microcracking? When do we stop rolling? Did we actually crack the cement treated base? And is there long-term structural damage by doing this? So actually, before the research kicked off on State Highway 47, that it's just, I guess, west of campus, it goes from University Drive, FM 60, over to State Highway 21, we were having some problems with organics in the subgrade. We'd lost our lime stabilization, and so we needed to bridge over the subgrade. So it was cost effective for us at that time to cement treat the base, but again, we didn't want to have those shrinkage cracks, and so we chose to microcrack the base along with the cement stabilization. And we tested with the FWD before, after we microcracked at 6 months, and then I think about a year later to look at long-term stiffness and the changes from this. But then when we started the research, we added the sections we'd already done on 47 for monitoring, and we built some sections on Interstate 45 frontage roads in Huntsville, and then at the Riverside campus. So in 2002, again, this is a long time ago, we went out and we cement treated 5 sections, and we all were microcracked between 1 and 3 days, and we moist cured. And on this, we had minimal to no transverse cracking. I went and looked at it again, and I still don't see any transverse cracking. We have some longitudinal cracking from the soil, but we don't have any transverse cracking typical to what you'd see from shrinkage from the cement treated base. And so what we did was, you basically use the same roller that you use to compact the base when you're treating it. And a couple days after you get density, you come back and you make 2 to 4 passes. Usually, I think 2 is probably what you need. And we just set it at the normal amplitude as if you were compacting, and we roll it again. So it's very simple, quick. You're using the same equipment. There's nothing special to do it. And then on Interstate 45, we also, the other thing we looked at was the design of the stabilization. And so for this, since it was under the research project, we had TTI do the lab mix design for the optimal stabilizer content. And it's real important when you do this, more is not better. The more cement you put in, the more cracking you're going to get. And so you want to get just enough cement in where it's not susceptible to moisture damage, but not so much cement that it's cracking, and then when you have cracks, you have paths for water to go. So on the interstate, it was a frontage road. We had a similar pavement structure. We had lime-treated subgrade, 14 inches of cement-treated base, and then 5 inches of hot mix over it. And some of these notes here at the bottom are from the end of the research, but I went back and looked at these, and these frontage roads still look really good. We don't have any problems with them. And this is a picture of the frontage roads of the sections that we microcracked. And then at the TTI's, out at the Riverside Annex, there's some kind of local roads that they have, and we set up test sections on those, and we used 4% and 8% cement. And we did the 8% on purpose because we wanted a high percentage of cement to show the problems you have when you have a lot of cement. And on these test sections, we dry cure, which just basically means that we didn't come back. And I know we've probably never had this problem on our projects where the contractor forgets to, apply some water to keep it cured. We also did a prime cure because the spec allows asphalt cure. And then we had some sections that we cracked at 1, 2, and 3 days. And then those sections that we micro-cracked, we wet cured for 3 days after. This is a cracking map. This section and this section are the 4% cement with the different processes, and these two are the 8% cement. So when we had 4% cement, the blue is the total cracking, and the maroon color is the cracking after the treatment. So you can see from this, we had the least amount of cracking when we micro-cracked on the second day, after 48 hours. And then this is the 8% cement, and this one was a little bit different. We had quite a bit of cracking on this section, but this one, the least amount of cracking was at day 1. And I think it was cracking without, just all by itself. We had some pretty severe cracks. And so then the total cracking, again, when you look at this, it looks like the day 2 was the best day. We did find, though, when we did the 45 frontage roads, that it was very cold. And when it's cold, as we all know, with concrete, with cement, the cooler temperatures retard the strength gain. And so we had to actually wait an extra day when we did the frontage roads just because the strength gain was so slow. So one of the things we found was if you looked at the severity of the cracks, this is a really large crack here. This crack, not so big. So, we may still have gotten some cracking, but the severity of the crack was greatly reduced. So we also tested with the FWD. Again, we tested before, we tested just after we cracked. We tested 6 months, a year later, so that we could look at the long-term strength. And if you look at these strengths over here on the side, 500 top mix. So, probably 1,000 is what is really high. So we had really good stiffness results. And one of the things that I thought was important is when we were deciding when to stop rolling, when we were actually cracking, we let the stiffness drop in half. So whatever we read with the FWD, we do one pass, we test again, and we do another pass, and we roll until we got a 50% reduction in stiffness. But over time, the strength gain on the control sections were the same as a strength gain on the microcrack section. which was really important because it showed that early opening to traffic on cement stabilized bases does not harm them, because we're going to have our strength gain over time, which helps with speed of construction. So if you're concerned that you're going to cement treat a section and you need to open it to traffic early, I think this research showed that we're not going to have long-term strength problems by doing that. So the conclusions from the research is, depending on the cement content, the microcracking improves the crack performance, the total length of the cracks, and also the severity of the cracks. Remember I showed that picture of how much wider the one crack was when we didn't microcrack. And but the greatest benefit is when we do our lab mix design in conjunction with the microcracking and make sure we don't get too much cement. We just, on one of my jobs in the Huntsville area, we just did a mix design, and we usually assume 4%. I don't think I've ever done a design in the lab that required more than 4% cement. And so we usually set up 4% for estimating purposes on our plans if we don't have time to do preliminary tests. But we were able on this project, after we did the lab testing, to lower from 4% to 3%. So it was about a $70,000 savings. So if you run the test and you can save the money, then you're going to pay for the test. So it's important to do these tests, and we can save a lot of money doing them. And it would have been nice if we would have had the time before we let the project to have run the tests and set up what we needed, but we didn't have that time. And so some other conclusions from the research was that if you have a high cement content, we may have to microcrack twice, which is what the European literature says. And we haven't tried that because, again, I haven't done any designs that I felt the need for a high cement content. And it doesn't hurt the in-service base stiffness, so again, we can open it early to traffic. It's not detrimental over time to the strength. Most conditions, we did 3 passes after 2 days of curing. And again, in the cooler seasons, you might have to stretch that out a little bit depending on how cold it is. They developed a pamphlet, and I've got in here in a second, I got a picture of it and the web link, and I think these are going to be posted online somewhere, so y'all can get the web link to their research pamphlet. Let's see. So, and then they also wanted to recommend some ways to maybe test to decide when to stop rolling, but we really haven't implemented any of that. Not everyone has an FWD, and usually if you make a couple of passes, it's doing it. By the time you get to 3 or 4 passes, you're starting to tear up the surface finish, and you need to stop. If you're getting that far, it's probably too much rolling, because you don't really see, every once in a while you might see some hairline cracks when they're actually rolling it, but you're not really seeing that. But a couple of passes usually is enough to do it. This is the pamphlet they made. It's a kind of a, I guess it's a quad fold thing. It folds up, and on this side they showed some of the results from the research, and they have some of the recommendations on there, like when you microcrack, what size roller you need, how many passes to make, those kind of things. And so this is a really handy little brochure. I refer to it a lot. So what we did in the Bryan district was we set up a general note, because again, they're using the same roller they have out there to compact it, and so we just set a general note and said when it's directed by the engineer to microcrack, they'll roll within from 24 to 48 hours, and then use a minimum 12-ton vibratory roller. So we were using these general notes, and we have been using these general notes probably since 2004. And again, we only use the notes if we're not going to open it immediately to traffic, when we feel like we actually need to have the roller do this and not have the traffic roll the base. So some important information to make it successful is, again, to do your lab tests and make sure you have the optimal cement content. Perform the microcracking 2 to 3 days. again, the same roller that you're using to compact the base was the one you need to microcrack it. And
What strengths are you currently using?
okay, Tom asked what tests that we're using to determine the optimum cement content. So we're using the Tex 120, which is the standard cement series test. And we're also using, I think it's 143, which is the dielectric test, and that's the test we use to moisture condition the samples. So basically, you make 2 sets of samples. One goes through the normal test method. We usually use 2, 3, and 4% cement as our targets on base. And then the other set sits in a ½ inch of water for that same week. And then we break those at the end of 7 days and compare the strength. And we're using an 85%. The strengths have to be within 85% of each other to get the minimum cement content. But I'm not as worried about minimum strength. I usually like to have at least the strength, the flex base confined. So if you look at our flex base specs, it's 175 psi at 15 with 15 psi lateral pressure. So I want it to be at least as good as that, and I bumped that up so that 85% of that was still hitting 175. Is kind of the target strength we do, because we're not looking for high strength, because the high strength means more cement means more cracking, and that's another problem. So high strength is not better, high cement content is not better. And what we've done is we've just done another implementation project with TTI to look at a faster method to do the lab testing, where we use instead of the 6x8 sample, our traditional samples, we're looking at molding 2-inch by 4-inch sample in Texas gyratory press. And so that has a lot of promise to it, and hopefully we'll be able to speed up the design process and also require a lot less material in order to do these lab mix designs. Okay, this is a picture from a FM 3436 in the Houston district, and it was done about 8 years ago. I think this is in Galveston, and we talked to I guess it was the area engineer. We talked to the area engineer, and he said the road still looks good. They don't have any problems with it. And over the years, I've had some different districts, different states, different places call and ask me about this. Galveston's one of them. I've had some other states call. Tom recently had to take a trip to the Dominican Republic, because I know someone's got to do the hard stuff. But they went down, and their policy is they microcrack everything. And they've had really good success with it. Their roads really look good. Other agencies, Caltrans, New Zealand, Zambia, Utah, other places are using this, and they're using the research that TxDOT did in conjunction with TTI. And so I think maybe more places other than TxDOT are using our research. And so I guess that's one of the reasons I'm talking about research we did 10 years ago. And this is a Caltrans note. It's very similar to what we do. 2 to 3 days later, they go in and they roll it again. They make 3 passes with a 12-ton roller. Same thing we're doing. In the new spec book, in items 275 and 276, there's some language in there that discusses microcracking, so it'll be in the new spec. You won't have to have the general notes. You may need to note to tell them specifically you're going to want to do this, but you don't have to put the long notes in describing the process. It's already in the new spec. And again, the picture on the left, this is what we're trying to avoid, and this is what we want to end up with. And I want to make another comment on the too much cement is a bad thing. We have a section on State Highway 7 right now that's under heavy oil field traffic, and we cement treated the base. We had some problems. Maintenance went back out, cement treated the base, and it looks worse than this now, because it's just too much cement, and it's, you know, shrinkage cracks are bad. You get those shrinkage cracks and those heavy loads, and it starts to deteriorate much faster. And so I would just caution, I think some of the main things are do the mix design, keep the cement content down as low as possible, and don't be afraid to open it to traffic early if you need to, because we shouldn't have problems from doing that. All right, questions? Yes, sir.
I may have missed it in your presentation, but does this process work just as good for subgrade as this base?
The question was, does the process work for subgrade or for base? We haven't tried it on just soil. We haven't felt, I guess, the need to do it. Again, we're keeping our, if we're using cement on soil, it's probably 3 and 4%. We haven't seen bad shrinkage cracks on that or with sand. If we're recycling the old roadway, then yes, it works. Any other questions? Yes. Okay, the question was, when we opened it to traffic, was there a lot of heavy trucks in the traffic stream? And the answer is yes, because one of the sections we did was on US 290 between Brenham and Hempstead, and that one has significant traffic. A lot of our farm-to-market roads have oil field traffic, a lot of heavy trucks, and so we haven't seen any issues with the heavy trucks. And again, a lot of these FM rehabs we're coming back and adding a layer of flex base also. But again, that kind of helps with the loading over time. There may be some problems when we open to very heavy trucks directly on top of the cement-treated base, like I'm having on State Highway 7, where there's just a seal coat on top. We may need to cushion that with some flex base or some thicker hot mix. Yes? The question is, have we done any testing with a slurry? And we haven't, but I think it has some potential, especially in town, places where you're worried about getting even distribution of the cement. I'd like to try it in some places, but we haven't. Any other?
Sorry, the two districts that have done it that I know of, the Beaumont districts did a good-sized project with slurry about 7 or 8 years ago, and Miles, who just left, they did a project up there in the Atlanta district. So there's some sections now that are doing the cement stuff.
Okay. Tom's comment was we have a couple of districts, Beaumont and Atlanta, that have done sections. I think Beaumont's the oldest, so 7 years. And so we have done some slurry sections. And as far as I know, they're holding up well.